Problem number 9 on the review. It says the professor's statistics exam, 88% of the students pass. Suppose the class had 43 students. So what we have here is a binomial distribution. And in our binomial distribution, we have our n, the number of trials, is 43, and our probability here is 88%, or 0.88. We're asking us the probability that exactly 30 students will pass. And so without having to use that complicated formula that they have in the book, we could just simply use our calculator. If you go to second and vars, which is really calling the distributions, and scroll down until you see binom PDF. So there's a PDF and a CDF. For this particular problem, there are exactly 30 students, so the word exactly will lead us to PDF. I'm going to do a binom PDF of our n, which is 43, comma, our p, which is 0.88, comma, and then 30. So when we have that, whoops, let's take away one of the parentheses, and then we get a really small probability. So that small probability is actually 0.0008. So what I would like for you to write down on your paper is you're getting the probability of x being exactly 30, and you put this into your calculator, binom PDF, and then you put in your n, your p, and the number 30. And in this particular example, you got 8.45, and then now if you leave it like this, 8.45, this is not correct because your probability has to be between 0 and 1. So let's put e to the negative 4 there, which says you move the decimal point 4 places to the left. And so this is really what you're looking at. For the next question, we're asking what the probability is for getting at least 35. If we virtually look at the probability distribution table, 35, and then this goes to 43, we want to add up all these probabilities from 35 on. And so the CDF, if you remember, only goes to from 0 up to a certain number, and then the rest here would be its complement. So to do this problem, first of all, the notation, we'd like to look at least 35, so x bigger than or equal to 35. And then we're going to use a binom. I'm going to leave some room here. Binom CDF, and then we're going to go 43.88 again, and this time we're only going to go up to 44, our CDF, and then we need to subtract that from 1, so it's going to be 1 minus binom CDF. Alright, so let's actually punch that in our calculators. We have a 1 minus, and then second function distribution, and this time look for binom CDF. This is the CDF function, 43, comma 0.88. Oops, there should be a comma there. Let's go back and second function, insert, comma, and then right arrow, comma, and oops, we're looking for 34. Sorry, 34. Alright, let's try that again. Binom 1 minus binom CDF, 43, 88, and then 34. And then if we hit enter, we get a probability of 0.9339. What's the probability that at most 30 students pass? So px at most means anything going up to and including 38, so less than or equal to 38. And this time we don't need the binom PDF, we just go from 0 all the way up to 38. So that would be another CDF, binom CDF of your n, your p, and this time you go up to and including 38. So let's figure out what that is. Second function, distribution, and look for the binom CDF. And then we're looking at 43, comma 0.88, comma 38. And I see a 0.59978 or 0.5998. Now, our expected values are mean, and standard deviation is sigma, our mean mu, and our standard deviation is sigma. And if you remember the formulas for these things, for a binomial distribution, computing these are a lot simpler than the other way. Without having to create a table and using any of those formulas, we have the mean is simply n times p, and the standard deviation is the square root of n times p times q, where q, remember, is 1 minus p. So let's take out our calculators. We know all those values already. N is 43 and p is 0.88. And then we get 37.84, and we can get our standard deviation if you press second function and the square button, which is the square root. And then again 43 times 0.88 times, now if you don't want to figure this out, you can just type in 1 minus 0.88. That's 1 minus p, or that's what q is equal to. Close the parentheses. And then I'll get 2.13. So our mean is 37.84. Our standard deviation is 2.13. That's problem number 9.